Good evening, everyone. Am I audible to you guys? Am I audible? Please don't reply me in chat because now I'll be teaching on the board, this virtual board. And if you are replying in the chat, I won't be able to understand anything. If you have any doubts, okay, then you can unmute yourself and you can ask me. I will not be able to see the chat. So we are going to start with the new chapter of integration. Okay. We have already completed derivatives, so I don't want you to learn more formulae. A lot of formulas can be done on the basis of derivatives only. So I'll start from there. Okay, an integration. Integration is also called as antiderivative. Integration is also called as antiderivative or as inverse function of derivative. If you just remember, okay, we have seen relational functions. Okay, so we have seen inverse functions also. So integration can be considered as an inverse function of derivative. Okay, strictly speaking, a little bit, it's not exactly that, but loosely I can say that yes, if derivative is a function, then integration is inverse of that. Actually, derivative is not a function; it is a process or procedure or an operation, and that is why we cannot directly technically see that, but from the understanding point of view I can say that okay, my integration is like an inverse of derivative. Okay, so opposite of derivative is what you are going to do. So you guys can see the screen, this small dots. This is what you can see on the screen, right? On this whiteboard, all the small dots are there. So when you apply okay derivative on anything, this is what happens. The entire thing gets okay converted into dots, and when you are finding out the okay answer of derivative, you find out at any one of these dots. When you apply derivative on any of the systems, what you do is you convert the entire system into small dots like this, and the result is obtained only for either of this dot. But I wanted the result for the entire system. What did derivative do? It did this kind of thing. So integration will do the opposite. Integrating means bringing all together. Means all these dots together I'll bring and again I'll create a screen. Okay, just the opposite process okay of that of the derivative. So since it is opposite, so it is going to cancel out derivative. Integration and derivative will cancel out each other. So suppose if I write this like this, d dx of and this dx. So both will cancel out each other and I'll get one. Integration, this symbol doesn't have any meaning without giving this variable. Integration means adding, and when I'm writing dx, it means I'm telling you add in this x direction. If I'm writing dy, then I'm saying that you add in y direction. If I'm writing integration with respect to dz, so I'm saying add in the z direction. If I am just saying integration, this doesn't have any meaning. Okay, so when I use this, I will have to use dx or dy or dz and so on. This integration and derivative will cancel out each other. Just remember this because both are inverse of each other. Okay? Why? Because both are inverse of each other. That is why both will cancel out each other. So now let's see the formulas. Instead of by hearting separate formula for integration, Okay, we'll do it on the basis of derivative. We have just understood now that derivative and integration are both inverse of each other and both can cancel out each other. So suppose I am writing derivative of sin x. The derivative of sin x is cos x. So now what I can do is, instead of remembering separate formulas, I can do put integration sign on both the sides. The integration of d dx of sin x dx is equals to integration of cos x dx. So now we just saw that this derivative and integration will cancel out each other. So what will remain is only sin x. So I'll get sin x is equals to integration of cos x dx. The integration of cos x is nothing but sin x. Derivative of sin is cos, then integration of cos is sin. As simple as that. Okay, let me show one more. If I write derivative of cos x, then derivative of cos x is minus sin x. So now I'll put integration sign on both the sides. So integration of d dx of cos x dx is equals to integration of minus sin of x dx. Here integration and derivative will get cancelled out, and this minus sign and taking it over here, so I will get minus cos x is equals to integration of sin x dx. So derivative of cos is minus sin, so integration of sin is minus cos. Okay, so don't by heart separate formulas for integration. If I say derivative of tan of x is sec square x. So now taking integration on both the sides, so d dx of tan of x dx is equals to integration of sec square x dx. So now derivative integration gets cancelled and I'll get tan of x. So integration of sec square x dx is nothing but tan x. The derivative of tan is sec square, so integration of sec square will be tan, and so on. Okay, derivative of log of x is equals to 1 by x. So again taking integration on both the sides, so integration of d dx of log of x dx is equals to integration of 1 by x dx. So here the derivative and integration gets cancelled out, so what remains is only log x. So I'll get log x is equals to integration of 1 by x dx. So derivative of log is 1 by x. So integration of 1 by x is log x. Okay. So on similar lines, you can do all the other formulas and integration what you've already done in derivative. Okay. Derivative of sine inverse of x is 1 upon under root of 1 minus x square. So again taking integrating on both sides. So integration of d dx of sine inverse of x dx, integration of 1 upon under root of 1 minus x square dx will be equal to, so here again derivative and integration gets cancelled, so what remains here is only sine inverse of x. I'll get sine inverse of x is equals to integration of 1 upon under root of 1 minus x square. Okay, so it's easy to remember. No need to by heart separate formulae for integration. Just take the formula of derivative. So question of derivative over will become answer of integration like this. Now if I take integration of this will become sine inverse of x. Okay, integration of 1 upon under root of 1 minus x square is nothing but sine inverse of x. Okay. So one additional thing I want to show over here is, suppose I have something like this. Uh, Suppose if I take tan inverse of x, so it is 1 upon 1 plus x square. So again taking integration on both sides, so d dx of tan inverse of x dx is equals to integration of 1 upon x square dx. Derivative integration again get cancelled and I get this. So integration of 1 upon 1 plus x square is nothing but equals to tan inverse of x. Okay. So we'll not by heart the formulas and integration. Instead, we'll just remember the derivative, and I can just say, okay, the integration of 1 upon 1 plus x square is tan inverse of x. The integration of this is sin inverse. Integration of this is log x. Okay, as simple as that. So just remember formulae of derivatives only. Yes, there are certain formulae which are different. Okay, and the integration from derivative that also we'll see. That also we'll see. Before that, I'll just like to add one more thing. Whenever you apply formulae over here in integration, you always do one thing is we add an integrating constant plus c. Here I'll do plus c. Okay, here I'll do plus c. Here I'll do plus c. Now, why do we do something like that? So I'll tell you the reason also why we are going to do this. Why should we add that plus c? Let's try to understand. So before going to that, let me give you one more. So this formula, integration of x raised to n, will be x raised to n plus 1 upon n plus 1. It's not like derivative. In derivative, we have d dx of x raised to n as n into x raised to n minus 1. Now here is the major thing which you have to understand. Here the constants get multiplied in derivative and in integration they will always get divided. So for example, integration of e raised to x dx will be e raised to x only. But suppose if I write e raised to ax, then this will become e raised to ax divided by a. But in derivative what happens? Suppose if I write derivative of e raised to ax, then it will be e raised to ax into derivative of ax, that will give me a. So whatever is there with the coefficient gets multiplied in derivative, whereas whatever is there with coefficient gets divided in integration. This is what you have to remember. Suppose if I have derivative of log of ax plus b, right? So what answer you'll get is 1 upon ax plus b, where chain rule and derivative of ax is a and derivative of b is 0. So this is what you get. So the coefficient which was there with the variable got multiplied. Now if I do something like this, integration of ax plus b dx, so that is going to give me integration of 1 by x is log x, so this will be log of x. Instead of x I have this ax plus b, so I write ax plus b, and then the coefficient with x is a, so I divide it by a. So what happened over here? Here the coefficient is getting multiplied, here the coefficient is getting divided. This is the major thing which you should remember when you apply the formulas in integration. Okay, here in derivative they get multiplied, okay, like this, and in integration they get divided. This is the thing which you should remember. Okay. So let's see which formulae are different over here. So in derivative we had derivative of a raised to x was a raised to x into log a. Here integration of a raised to x will be a raised to x by log a. This is the different formula over here. Next, which I have already showed you, d dx of x raised to n was n into x raised to n minus 1, and here integration of x raised to n dx will be x raised to n plus 1 upon n plus 1. Every time you will have to put plus c over here. So these are the two formulas which are different. Okay. So let's try to understand why I'm doing this plus c. So suppose if I have something like this, y is equals to 5x cubed plus 3x squared plus 2x plus 8. Now what I do is I take derivative of this. So when I take derivative of this, 3 into 5, so this will become 15x squared plus 3 into 2, so this will become. Till where you were able to hear students? Students, till where you were able to hear? Are you there online?
Sir,
Till where you were able to hear?
so now we are available.
No, means till where you were able to hear. I also did not know when the meeting got ended.
Sir,
Okay,
well,
just
till that integration of a log x, ax log
till
x, that thing.
a lot of things I missed. Okay, again I will have to teach. Okay, no worries. Okay, so I'll just do once again. So I was just saying that whenever you do any formula, suppose if I write e raised to x dx, so integration of e raised to x is e raised to x plus c. Whenever you write any formula, you'll always do plus c. Why? So let me take a very simple example. I take y is equals to say 5x cube plus say 3x square plus say 2x plus 8. I have some function like this. Now let me take its derivative. So when I take its derivative, I'll get a derivative of 5x cubed. So that will be 15x square, derivative of 3x square, that will be 6x, derivative of 2x, that will be 2, derivative of 8 will be 0. So if I'm saying that my integration is inverse of derivative, then when I take integration of this, I should get the same function. So I'm doing this integration of 15x square plus 6x plus 2 the whole dx. What I'll do is I'll separate the integral sign to each and every one separately. So 15x square dx plus integration of 6x dx plus integration of 2 dx. So finally I'll get constants will always come outside derivative
Sir,
integration limits. Yes, what happened?
sorry to interrupt, sir. That screen is not visible now.
Screen is not visible. Sorry, just a minute. Huh?
Yes, sir.
Now is it visible?
Yes, sir.
Is the screen okay? Okay. So here you can see whenever we take we do an integrating constant. Why do we add? That is what I'm trying to understand. Make you understand. If I'm taking a function, I'm taking its derivative. So if my integration is antiderivative, then by performing integration of this derivative, I should get this same function. Okay. So let us try. So now I'm taking integration of this derivative. So constants will always come outside derivative, integration, limit, summation, and so on. So this constant will come outside integration. So 15x squared dx. 6 will come outside integration of x dx. 2 will come outside integration of dx. And here derivative and integration gets cancelled out. So what only remains is y. So here I'll get y is equals to, so I get y is equals to 15 integration of x square. So we just saw integration of x raised to n is x raised to n plus 1 upon n plus 1. So this will be x raised to 2 plus 1 upon 2 plus 1. So that will be x cubed by 3 plus 6 integration of x. X can be written as x raised to 1. So x raised to 1 plus 1. So that will become x raised to 2 by 2 plus 2 integration derivative gets cancelled. Okay, you just get x over here. Integration of okay dx is x. So 3 ones are 3 fives are, so you get this 5x cube. 2 ones are 2 threes are, so you get 3x square plus 2x. So till here you have got, see here, same value of y you have got, but you did not get this plus 8. Now, why you did not get this plus 8? Because derivative of a constant is 0. So if in the original function there is some constant, and if we take the derivative, what will happen? Its derivative will become 0 and that constant will not be there. So now, if I'm not adding if I'm not adding an integrating constant over here, so then I'll not be able to account for this 8, which got 0, which became 0 due to derivative. And hence, to take into account all the constants which became 0 in the process of derivative, we have to add this integrating constant. So whenever you write any integration formula, okay, keep in mind that you always have to do this plus c. Okay, you will always have to do this plus c whenever you use any integration formula. I guess this chapter must have already been started in your school and lot of these must have already been covered. Okay, I guess is the chapter already started in the school? Did the chapter start in the school? Students?
Yes, sir.
So you already have an idea, right?
Yes, sir.
If I don't write all the formulas, it will be fine, right? So if I
Yes,
don't
sir.
write the formulas, it is right. Okay. So I'll directly start with the numericals. Before that, I'll just explain you because I'm going to teach you in a different manner. Generally what happens is when a teacher is teaching you and when the teacher has already written the topic, so you already know this particular numerical is in which topic because this topic is going on. Therefore, it's easy to recognize and solve the numerical. But what happens in exam is when you see the numerical, you don't know it is in the which topic. Therefore, solving it becomes difficult, and especially in integration, it becomes very, very difficult. Okay, we generally all the teachers will always say that integration is one of the most difficult topic. The reason is this because after seeing the numerical, it's difficult to okay understand what to.
Sir, you muted yourself.
Uh, am I audible now? I'm facing some internet issues today, and that is why what is happening is again and again I'm going outside the meeting. Am I audible now? Students, am I audible now? Students, am I audible now?
Yes, sir.
Please respond.
Yes, sir.
Okay. Yes, so I was saying about, okay, I'm classifying this chapter into certain categories. What is an example of numerical we don't know how to solve. But if we are able to categorize into any of this okay categories, then we'll be able to solve. That is the reason why I'm going to teach you integration in some different ways. What I've done is I'm breaking the entire chapter to certain types of numericals. This is as per me and not per any textbook. Okay. First type of numericals as per me is formula based, where you can just use the integration formulas and then you'll be able to solve the trigonometry or differential formulas. And the second types of numerical as per me is rational fraction type. This will be numericals of the type P by Q. Then third type of numerical as per me is methods of integration. In that we have first method as substitution method. Second method we have integrating by part. The third method we have a method of partial fractions. There is a little bit difference between partial fraction and rational fraction type. Then I classify certain type of integration as special integration. So here we are going to use some different types of formula which were not there in derivative, and here we use some special formula. So here I have certain types. So entire chapter I am going to divide into these three types of numericals. So just by seeing the numerical and classifying will help you understand. So if we go through the chapter, I will explain you how to understand that this falls into which category. But this is important. This screenshot. This is very important. If you are able to classify, then any numerical this type can be solved by the same numerical of this type can be solved by the same method. So if you are able to classify the numerical which it fits into which type of category, then it will become very, very easy for you guys. So this is what I'm going to do. Then there's integration chapter. This is the part of indefinite integral. We call it as indefinite integration. Or it is also called as infinite integration. Why? Because there is no starting point, no ending point. Therefore, it is infinite or infinite integration. After this, we are going to study something called as definite or finite integration, which is very much used in your physics, where we say from where we have to start and where we have to end. Basically, we are going to give the limits. Right? We are starting from this point and end at this. Then we are going to see application of integration. Today we saw application of derivatives. We are going to see application of integration. But first I'm going to do this. Then I go for this. So I'm going to as a separate, and I'm going to treat this two as separate chapters. So now first few lectures will be about indefinite and infinite integration. This is very important. Without having a grip on this, going on this too will be very difficult. You should have grip on this entire indefinite integral chapter. Then only definite or application will become easy for you. Otherwise, this 2 will become very difficult. Okay, so let's start. Let's actually start with the first type of numerical, that is formula based type 1. So as I go to different types, I'll keep on explaining you, okay, how to classify. So today I'm going to start with type 1. So first type of numericals which directly formula based or which can be converted by little simplifications into formula based. So first what I'm going to do is I'm going to just show you some basic types of numericals so that you understand what and how I'm categorizing it, and then we'll go with the exam numericals, JEE and AIEEE numericals. So let's start. So I have something like this. See, I have this integration of sin x plus 1 by x plus 1 by cube root of x dx. So what you can do is just separate the integral sign, give this integral sign to everyone separately. So I'll get integration of sin x dx plus integration of 1 by x dx plus integration of 1 by cube root of x dx. So I'll get integration of sine. So we directly have integration of sine is minus cos. Why? Because integration of cos was minus sine. So integration of sine is minus cos x. Plus this is also direct formula, integration of 1 by x dx is nothing, log of x. Now we have not seen any formula for this. Why? Because there is not. We have seen, but this cube root can be written as x raised to 1 by 3. Now this goes up. So whenever you take the powers up and down, the sign of the powers change. Therefore, I'll get I equal to minus cos x plus log of x plus integration of this will go up, so it will become minus x raised to minus 1 by 3 dx. So which can again be written as integration of cos x plus log of x plus integration of x raised to n is x raised to n plus 1 upon n plus 1 plus c. So this will become minus cos x plus minus 1 plus c, so that will become 2 by 3, so that will become x raised to 2 plus c. Or you can also do like this. I said that whenever you do integration, you have to put an integrating constant. So this could have, this you could have write like that also. After applying the formula, you could have written integrating constant C1 for this first integral. Then you could have written something like this, log of x plus C2. After doing this integration, this integrating constant, and after doing this integration, you could have done like this also, x raised to 2 by 3 upon 2 by 3 plus C2. You can write also, sorry, C3. And then instead of C1, C2 and C3, you can simply write only one integrating constant, that is minus cos x plus log of x plus x raised to 2 by 3 upon 2 by 3 plus c. I just mention over here that c is nothing but c1 plus c2 plus c3. It's your wish if you want to write like this or if you want to write like this. Okay, what you can do is you can take all the integration and at the end you can put this integrating constant. That is also fine. Or after every integration, you can put this integration constant, and at the end, you will just write one integrating constant and you will mention that this integrating constant is nothing but this. So You can go this way also, you can go this way. So I'll prefer this way. Okay, throughout this chapter, what I'll do is first I'll perform all the integrations, and at the end I'll just write one constant of integration instead of every time writing the constant of integration. Okay, both the methods are allowed, whichever you want, you can use it. Okay, everyone can take the screenshot of this. Okay, let's go for the next type. Means same type only, next numerical. Now I have this integration of tan of x plus cot of x the whole square dx. So I don't have direct formula for this. So first what I'll do is, there is no chain rule such thing in integration. In derivative we could have directly applied the chain rule, first this then this, we would have taken derivative of this, but we don't have any kind of chain rule in integration. Whichever numericals of chain rule were there in derivative becomes integration or substitution over here. Okay, let's try to this. Let's try to understand how to solve this. So I'll just do simple thing is, okay, I'll just expand this. So a square plus b square plus 2ab. So this will become integration of tan square x plus cot square x plus 2 times tan x into cot x the whole dx. Okay, so which can further be written, what I can do is I can separate the integral sign. So I can do integration of tan square x dx plus integration of cot square x dx plus integration of 2 will go outside because it is constant, tan x into cot x dx. Now we don't have direct formula for tan square x and cot square x. Okay, so therefore we'll have to write it in some other form. So we know that 1 plus tan square x is sec square x, right? So tan square x can be written as sec square x minus 1. Similarly, I can do for cot x. Similarly, this tan x and cot x. So tan x is nothing but 1 upon cot x. We know that. So here instead of tan x, I can write 1 by cot x. So this will become integration of tan square x can be written as sec square x minus 1 the whole dx. Similarly, cot square x can be written as integration of cosec square x minus 1 the whole dx. 2 into integration of tan of x can be written as 1 by cot x into cot x into dx. So this cot and cot gets cancelled over here. Here I can again separate the integral sign. So I will get integration of sec square x dx minus integration of 1 dx. So that will be nothing but integration of dx plus similarly here also integration of cosec square dx minus integration of dx plus twice integration of dx. So this minus dx, that will be minus 2 dx, and this is plus 2 dx. So this will get cancelled. Our integration of sec square x. So we know derivative of tan is x square. So integration of sec square is tan. So this will give me tan of x. Derivative of cot is minus cosec square x. Okay, derivative of cot is minus cosec square. So integration of cosec square will be minus cot. So here I will have to do minus cot. So this will be minus cot of x plus c. So this will be my final answer. Hope you have understood. If you have not understood any step, then you can ask me. Please take the screenshot of this, and if you're not understanding any step, please ask me. Okay, don't hesitate to unmute yourself and ask me. Okay, I hope everyone has taken the screenshot. Okay, let's go next. I'm just taking some preliminary numericals so that you just get idea, okay, how to solve the numericals. Next, integration of e raised to 4 log of x minus e raised to 5 log x upon x raised to 5 dx. So now this is again, I'm saying it is formula based only because I can write this as just using the properties of log e raised to log of x raised to 4. Similarly, here also I can write e raised to log of x raised to 5 upon x raised to 5 dx. Now e raised to x is NT. This is NT log and this is log. So this log and NT log will cancel each other. So when the log and NT log cancel each other, so here this log and NT log both will cancel each other. So what remains is x raised to 4. So x raised to 4 minus log and NT log cancels each other. What remains is x raised to 5. So x raised to 5 upon x raised to 5 dx, which can further be written as x raised to 4 upon x raised to 5 minus integration of x raised to 5 upon x raised to 5. So here what will remain is x, and here this is cancelled. So this becomes integration of 1 by x dx minus integration of dx. So integration of 1 by x dx is log of x, integration of dx is x, and there's an integrating constant plus c. So again, I'll call it as formula based only because I'm just applying the property of log and then I'm able to solve it. Okay, and therefore I'll call it as that only. Let's see one more. I have something like this: integration of root x plus 1 upon x plus root x dx. So let's see. So I can write like this: x root of x plus 1 upon this x can be written as, x can be written as root x into root x plus this root x. X can be written as root x into root x. So this becomes integration of root x plus 1 upon here, and take root x as common. So what will remain here is root x, and what will remain here is 1. So now this root of x plus 1, root of x plus 1 gets cancelled. So I get integration of 1 upon root x dx. So root x means x raised to 1 by 2. If it goes up, so it will become x raised to minus 1 by 2. So I can write it as x raised to minus 1 by 2. So by applying the formula x raised to n plus 1, so that will be minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus c. So that will give me x raised to 1 by 2 upon 1 by 2 plus c. This 2 go up, so this becomes 2 into x raised to 1 by 2 plus c. So x raised to 1 by 2 is nothing but square root, so that is 2 root x plus c. Okay, you could have also remembered as like that, Okay, that integration of root x, or sorry, derivative of root x is 1 by 2 root x. So integration of 1 by 2 root x. Okay, root x. This is also you could have remembered. I hope you are getting it. Okay, let's move ahead. Let's see one more. Okay, so we have something like this: integration of 1 upon root of x 1 minus root of 3x minus 5 dx. So now how to solve this? So what I'll do it again is I'll try to simplify, I'll try to rationalize the basic algebraic principle. Okay, what we know is that there should not be any square root or imaginary number in the denominator. So whenever there is an imaginary number and okay denominator, we take conjugate. And whenever there is square root in the denominator, we do rationalization, right? So this is what I'm going to do here also. So just using the similar principle, I can just write, okay, 1 upon root of 3x plus 1 minus root of 3x minus 5. So I'll multiply and divide by root of 3x plus 1 plus root of 3x minus 5 upon root of 3x plus 1 plus root of 3x minus 5. So this will become a minus b into a plus b is a square minus b square. So when I do that, so this square and square root gets cancelled. So I get 3x plus 1. So this is a square minus b square. So this is 3x minus 5. And here I'll get this square root of 3x plus 1 plus square root of 3x minus 5. So I'll get this is equals to integration of square root of 3x plus 1 up to root of x minus upon this plus 3x minus 3x gets cancelled as minus becomes plus. Okay, so 5 plus 1 that will become 6. So this will come outside the integration. This comes outside integration, so this will become 1 by 6 under root of 3x plus 1 plus under root of 3x minus 5 the whole dx, which will further give me 1 by 6. Now I can do is I can separate this integral sign, and square root means this can be written as 3x plus 1 raised to 1 by 2 plus integration of 3x minus 5. Since it is square root, I can write raised to 1 by 2 dx. So I get 1 by 6. This will become 3x plus 1 raised to 1 by 2 plus 1 upon 1 by 2 plus 1. Now one more thing, if you just remember, I said that whatever coefficient is there with x, you have to divide. So you will have to divide with this 3 over here. Remember, this is very important. Plus 3x minus 5 raised to 1 by 2 plus 1 on 1 by 2 plus 1 2. What is coefficient with x? 3. So you will have to multiply with this 3 and then you can write plus c over here, something like this. So I get 1 by 6. So raised to 3 by 2. So here also this 3 by 2, this 2 goes up, and this 3 and this 3 I'm taking common outside. So 6 into 3, this becomes 18. Here I can write it as 18, 1 by 18 3x plus 1 raised to 3 by 2 upon this will also be 3, right? 1 by 2 plus 1, that is 3 by 2 plus 3x minus 5 raised to 3 by 2 upon 3 by 2 plus c. So this 2 will go up, this 2 will go up, and then this 3 will come outside, so which is further written as 2 upon 3 into this 18 into 3x plus 1 raised to 3 by 2 plus 3x minus 5 raised to 3 by 2 plus c. To say I've not done anything else, I've just used simple algebra, what we are doing since our school times, not in 11th and 12th. We are doing this since 9th and 10th standard, right? So that methodology only I'm applying, and then I'm just applying the formula of integration. Hence, I am keeping this in type 1, which I call it as formula type numericals. Let's see next. Everyone, please take the screenshot of this. Please take the screenshot of this, everyone. I hope everyone has taken the screenshot. Let's do next. Integration of x cube upon x minus 1 dx. Okay, so let's see how to do this. So again, what I'll do is I'll just do adjustment over here. X cube minus 1 plus 1. I'm just adjusting 1, which can further be written as x cube minus 1 upon x minus 1 plus 1. I have purposely done this adjustment, and this 1 can be written as 1 cube. So we have this formula a cube minus nothing but a minus b into a square plus ab plus b square. And then I can cancel out the x minus 1 and x minus 1, and that is why I have done this adjustment. Okay? Because we don't have direct formula for this. So let's say this, so I'll get I is equals to integration of this x cube minus 1 cube can be written as x minus 1 to x square plus a 1 into x plus 1, that is 1 upon x minus 1, and this can be written separately as 1 upon x minus 1 integration. So here this x minus 1 gets cancelled, so I'll get integration plus x plus 1 dx, and integration of 1 by x is log x, so this will become log of x minus 1 plus c. Okay, there is no coefficient with x, so I'm not dividing with anything. Suppose if I had 3 minus 1, I would have divided here by 3. Here there is no coefficient with x, therefore I'm not dividing. Now you can do this separately, or you can just consider in mind that you are separately integrating x square. So integration of x square is x cube by 3. Integration of x is x square by 2. And integration of 1, that is dx, is x plus log of x minus 1 plus c. So this is my final answer. If you want to further simplify it, LCM of the denominators. Okay, or you can keep it like this. Okay, if you want, you can take this LCM 6 and then you can take it over here, or you can keep it like this. Okay, so these are some numericals in type 1. Let's see some more. Next, I have something like this. Integration of sine of 5x into cos of 7x dx. So we have a separate formula for sin x, we have separate formula for cos x. We don't have like this formula. So we will have to apply the trigonometric formula. We have this 2 times sin cos a 2sc. So whenever we have this mixed formula, if you remember, I've said that this is s plus s is 2sc and s minus s is 2cs. So here for applying this formula, I have to adjust 2 over here. So what I'm going to do is I'm going to adjust I is equal to what I'm going to do is I'm going to adjust this 2. Multiply and divide with 2 sin 5 into cos of 7x dx. So now this becomes 2 times sin x plus s, which means sin plus b plus sine of a minus b. So I'll get I is equals to 1 by 2. I've adjusted the integration of this will become s plus s means sine of a plus b. So sine of 5x plus 7x, that will be 12x plus sine of 5x minus 7x. So that will be minus 2x. Now sine of minus theta, so this will become 1 by 2 integration of sine 12x minus sine of 2x dx. Now integration of sine is minus cos, therefore I'll get I is equals to 1 by 2 minus cos of 12x divided by 12. Okay, and whatever is coefficient of x, you will have to divide the coefficient of x, so divided it by 12. Minus integration of sine is minus will become plus. The plus cos of 2x divided by 2. Remember, whatever is the coefficient of x, you have to divide by. So this is the final answer. Okay, please everyone take the screenshot. Everyone, please take the screenshot of this. I hope everyone is taking this screenshot. Okay, let's do one more. So integration of 1 upon 1 minus sin x dx. Generally, all the trigonometry type will, generally all this will fall in type 1 only. Because there is lot of ways of simplifications possible in trigonometry. A lot of trigonometry formulas are there. So you can always go for that. So what I'm going to do over here is 1 upon 1 minus sin x. So I'm going to multiply with its like kind of a factorization kind of thing. So 1 plus sin x, multiply and divide by 1 plus sin x dx. So I'll get over here a plus b into a minus b is a square minus b square. So 1 square is 1 minus sin square x. And above I'll get 1 plus sin x dx. So I'll get 1 plus sine x upon 1 minus sine square x is nothing but we know cos square x. This will become cos square x dx. So I'll just simply separate it and I can write it as 1 upon cos square x plus sin x upon cos square x the whole dx. Now 1 by cos is sec, so this will become sec square x, and sin x by cos x, so this will be nothing but sin x by cos x into 1 by cos x. This is how I can write cos square x also, right? So this will become integration of sec square x plus sin by cos is cot x and 1 by cos is cosec. Sorry, 1 by cos is sec. Sin by cos is tan, sorry. Okay, sin by cos is tan x, so this will become tan x. 1 by cos is sec, so this is sec x, the whole dx. So now I can separate the integral sign and I can write it as integration of sec square x dx plus integration of tan of x into sec of x dx. So integration of sec square, we know derivative of tan is sec square x. Therefore, integration of sec square x is tan of x. Similarly, derivative of sec is sec x into tan x. Therefore, integration of sec x into tan x will be nothing but sec x. Why? Because derivative of sec is sec into tan. Therefore, integration of sec into tan will be sec plus c. So this is my final answer. So I hope everyone understood. Whenever generally it is a trigonometry numerical, okay, be sure that it is going to be formula type only. So what happens in formula type? You do some algebra, you simplify it, and then it gets converted into just the formula whichever is there in integration. We directly use it. We don't have to do anything else. Okay, so that I classify into formula type. I hope everyone has understood and everyone has taken the screenshot. So that's it from today, okay, because it's already 7:20 also. The next types we'll see in the next class. I'll share this recording once I receive the link on my Google Gmail. I'll send this recorded lecture in the group, okay? Have a nice day ahead.